Good evening, everyone. Am I audible to all of you? Can anyone confirm once?
Yes, sir.
Yes, sir.
Okay, perfect. Let's wait for one more minute and then we'll start. Okay, so I think all of you are here, so we can get started. So let me present the screen. So in the last class, we have discussed the idea of how we are going to construct the integrating factors to make the differential equations exact, right? That was what we were basically discussing. And this was the last question at which we stopped. So did anybody complete this? Finding the integrating factor and solving the differential equation?
Yes, sir.
Okay. So what is the integrating factor and the solution? Just a minute.
So the integrating factor I got is 1 by 2 x square y square.
1 by 2 x square y square. Okay. So the integrating factor is 1 by 2 x square y square. All right. And what about the solution?
So minus 1 by 2 xy plus 1 by 2 log x minus 1 by 2 log y equals to c.
Minus 1 by 2 xy.
Yes, sir. 1 by 2 xy. Completely, it is under the denominator only.
Okay. Minus 1 by 2
Plus
xy
1 log x
plus half log x
minus half log y
minus half log y.
equals to c.
Okay. All right. Others? Did anybody give this a try? Others? Anyone? Okay, no worries. Maybe you can just take this question down and cross check for yourself if you're getting this same answer, right? All right, so this is the integrating factor and this is the solution that we should be getting for this differential equation. So today we'll continue with, I would say, a kind of revision of the entire first order differential equations that we have discussed. So we'll discuss some questions on all the topics that we have covered so far, all right? All the portions of differential equation. So let's take the first question for today. The differential equation is exact for four options – . 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, any value of A and B not equals to 2. Option B, any value of A, B equals to 2. Option C, any value of B, A equals to 2. And option D, any value of A. Okay. So any guesses, anyone? How should we start with this?
We'll just calculate del m by del x and del
Correct.
n by del y and
Absolutely. So over here, my M is 3a square x square plus by cos x, and my N is 2 sin x minus 4a y cube, right? So partial derivative of M with respect to y is how much? What are we getting?
3a square x square cos x b means 3a square x square b cos x.
The partial derivative.
Oh, no, sorry.
It will be only b cos x, right? First term will be 0. And del n by del x will be 2 cos x. So that means b should be equals to 2. Correct? So that means for exactness, the only restriction that we are getting is that b should be equals to 2. There is no restriction on a. That means a can be any value, any real number, since there is no restriction. So which option is matching? Correct. Option B. Because you are not getting any restriction on a, right? Exactness does not depend upon it, so to say. So I can basically take any possible value that is feasible. All right. Is it fine with all of you? Any questions? Okay. So let's move on to the next one. The differential equation x square minus x dy by dx is equals to 2x minus 1 into y, where y of x naught is equals to y naught has a unique solution if x naught comma y naught is equals to what? Option A 2 comma 1, option B 0 comma 0, option C 1 comma 2, and option D none.
We should apply separation of variables, then it will be easy.
Yes. So how are we going to proceed with that?
Just 2x minus 1 by x square minus x dx dy by y will be in the left side, and then we will take x square minus x equal to z. So differentiating it, it will be 2x minus 1 dx z dz something. So
Correct. Correct. Absolutely. So I'll bring all the y terms to the left and take all the x terms to the right. And integrate both sides. Correct? And for the RHS, if you take your x square minus x to be some z, then your 2x minus 1 dx will be equals to dz, right? So that means you have log of mod y is equals to log of mod x square minus x plus c, right? Okay. And just to get this equation in a little bit more clean form, instead of writing c, I can write this as log of c, correct? So if I do this, it will become log of mod y is equals to log of mod x square minus x into c. So that means your y is equals to x square minus x into just c, correct? This is your general solution, right? And now since we are given this additional statement over here, I hope all of you can understand that this means that you can find out the value of c and obtain the particular solution, right? So after this, y of x naught is equals to y naught, matlab y naught is equals to x naught square minus x naught into c, correct? So now you just put these values and check. So if you put your x naught y naught as, what is the first option, 2 comma 1, what are we getting? Can anyone just tell me if you replace this into expression?
We get C is equal to 2.
Kot?
Sorry, C is equal to 1 over 2. Basically, 1 is equal to 2 squared minus 2 times C.
Okay, so 1 is equals to 2 squares of 1. So c is equals to 1 by 2. Right? So we are getting one possible value of c. So this option qualifies. What about the others if you check? If you put 0, 0, what are we getting?
0.
0 is equals to c. Sorry, 0 equals to 0, right? So from here we are not getting anything. This is out. What about 1 comma 2?
We don't get anything as we have 0 on one side. So, multiple solutions exist again.
Okay. Yes. So this is 2 equals to 1 minus 1 times c. So that means 2 equals to 0. This also does not make any sense, right? Multiple solutions. So that means the only case where we can get a unique solution is when c equals to half or x naught y naught is equals to 2 comma 1. So the correct option is option A. Okay. Is it fine with all of you? Any questions? All right, perfect. So moving on to the next one. The solution of the differential equation dy by dx is equals to y squared, where y of 0 equals to 1 exists for all option 1 for all x belonging from minus infinity to open interval 1, option D for all x belonging to real number, option C x belonging to some intervals 0 to a where a is greater than 1, and option D x belonging to interval 1 to a where a is. Okay, so how can we start with this?
So let's find y explicitly in terms of x, and then we'll find the condition for what values of x would y be real or something like that, I presume.
Correct, correct. So in order to do that, we will first solve the differential equation, right? Only then will we get y as a function of x. So my differential equation is dy by dx is equals to y squared. So this is a pretty simply variable differentiation, variable separation, right? And you will integrate both sides. So what are we getting after integration?
Y equal to y square x plus 1.
Repeat once more.
Means y equal to y square x plus 1.
Y equals to y square x plus 1.
Um,
Now, y square x component shouldn't be there, right? Because we have variables separated, so we shouldn't get this. Now, there is some
So
error.
minus 1 by y is equals to x plus c.
Yes, minus 1 by y is equals to x plus c. Yes, this is correct. Integration of 1 by y square is minus 1 by y, and integration dx is x plus c. Okay, and then y of 0 equals to 1. What does this mean? That if you put x equals to 0 in the expression, you will get y equals to 1, right? So that means minus 1 is equals to 0 plus c. So your c is basically minus 1. So that implies if you replace it, minus 1 by y is equals to x minus 1. That means y is equals to 1 upon 1 minus x. Correct? Is it making sense to all of you? Now, can anyone tell me how to select the correct option in this case? This is the solution. Now, how do we link it?
all the values of x for which y happens to be defined or something.
Yes, correct. Absolutely. So the question is the solution of the differential equation exists for what values of x? Okay, so the solution will exist only when y exists, right? Now, if you check over here, this solution will exist only when x is not equals to 1, right? It shouldn't be 1. For all other values of x, you will have a particular value of y. But the only exception is x equals to 1. Correct. So you need to see out of these four ranges, which of the four does not include x equals to 1. That will be the correct range. Correct?
Option A.
Option A. Yes, absolutely.
Option C will also be correct, right?
A is some integer greater than 1, right? So that means it will include 1. It's a closed interval, right? So if A is 2, that implies that it is closed interval 0 to 2. 0 to 2 includes 1, right?
Oh, yeah, yeah.
Correct.
Only
So that,
option 1, A.
yes, exactly. Okay. Is this understood by everyone? Any questions? Okay, perfect. So I guess we can move on then. Which of the following is not an integrating factor of the differential equation x dy minus y dx is equals to 0? Option A, 1 upon x square. Option B, 1 upon x square plus y square. 1 upon xy, xy. Okay. So take a close look at the question once more. The question is which one is not an integrating factor? ऐसा नहीं बोला है कि find the integrating factor. So the best way to proceed with this question is take all the options one by one and check which of the options is making the differential equation exact, right? Okay. So if we start with, let's say, option A, if your integrating factor is 1 upon x square, then what is your differential equation if you multiply with 1 upon x square? 1 by x into dy minus of y by x square into dx is equals to 0, right? So can anyone check and tell me if this is exact? Is it?
Yes.
Okay, perfect. So that means this option is out. So this is exact. Hands out. What about option B? If your integrating factor is 1 upon x square plus y square, then it is x upon this. So check this all of you, if this is coming out to be exact. So for this question, your n is minus y by x square plus y square, and your n is x by x square plus y square, right? So you have to do del m by del y. So that will be minus stays outside, second into derivative of the first minus first into derivative of the second divided by x square plus y square whole square. Correct? So that will be minus 2y square plus y square minus y square. So this will become y square minus x square divided by x square plus y square whole square. What about del n by del x? Second derivative of the first minus
This
it's matching, right? So this will be y square minus x square. So this is also exact. So that means this is also not possible. What about this one? 1 by xy. So in that case, the integrating factor will become 1 by y dy minus 1 by x dx equals to 0. What about this?
This will be exact.
This is exact, yes. So one option remains, obviously वही होगा, but you can just check also for once. If your integrating factor is x by y, then that will be x squared upon y dy minus x dx is equals to 0, right? So in this case, your m is minus x, n is and del n by del y, sorry, del n by del x is 2x by y. So that means these two are clearly not equal. Okay. So this will be option D over here. All right. Is it fine with all of you? Any questions? Okay, perfect. So let's move on to the next one. If the integrating factor of the differential equation x to the power 7y squared plus 3y dx. Y minus x dy is equals to 0 is x raised to the power n, y raised to the power n. Then mn is equals to how much? Option A minus 7 comma 5, option B minus 1 comma 5, option C minus 7 comma 1, option D minus 7 comma minus 1.
We will just try to establish the equation by doing that del m by del y equal to del n by del x because to solve it, it
So
has to be
yes,
exact.
correct, correct. So what is
And
your
m
m and n in this case? What is your m and n?
what? Yeah,
What is
m
your
is x power 7 y square plus 3y. I think.
no? This has
Yeah.
the integrating factor, right? So that means this will become exact after you multiply with the integrating factor.
Oh, yes, 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 yes.
That's why I asked this question. That is the common mistake. So these are your m and n's, right? अगर इस differential equation का integrating factor है, that means the differential equation by default is not exact. Otherwise integrating factor नहीं होता, right? So after multiplying your m and n with the integrating factor, will your differential equation become exact? So with this m and n, your del m by del y will be equals to del n by del x. Is this making sense to all of you? Any questions? Right? Is it fine with all of you? Is it making sense? So now what will be your del m by del y? Can all of you just tell me once you're done with the calculation, what you are getting?
N plus 2 into x to the power 7 y to the power n plus 1 plus 3 into n plus 1 into x to the power n y to the power n.
Okay, that was a big expression. Let me just simplify this, I guess. So if I try to partially differentiate del m with respect to y, so x to the power m will be outside, right? So second into derivative of first plus first into derivative of second. Correct? Del n by del x. X से करने के लिए y to the power n is outside. So second into derivative of first. So that will become 24x to the power 7 times y minus 1 plus m into y raised to the power m minus x raised to the power m minus. Okay. Is this matching with all of you? Can anyone check and tell me if this is fine? Yes, anyone? Are we getting this? So I'll just go one step more over here. So this can be written as x to the power m into y to the power n taken common, 2x to the power 7y plus 3 plus x7y square plus 3y into n by y, right? And this will become x raised to the power m into y raised to the power n, 24x raised to the power 7y minus 1 plus 3x to the power 8y minus x into m by x. Agreed, everyone? Is it fine? So when you equate them, these two will cancel out basically. So del m by del y is equals to del n by del x. So x to the power m, y to the power n will cancel from both sides, and you are left with only the part inside the brackets. Plus, if you divide it by the y, that will become x to the power 7y plus 3 is equals to 24x to the power 7y minus 1 plus, if you divide it by the x, that will become 3 times x to the power 7y minus 1. Alright, so if you group all these terms, 2x to the power 7y plus n times x to the power 7y, this is one part, plus 3 plus 3n is equals to 24x to the power 7 minus 3m x to the power 7y, correct? And minus of 1 plus n. All right. Is it making sense to all of you? Any questions? So x raised to the power 7y can go out common. This will become 2 plus n. And if you bring all the other terms to the left, so minus 24 plus 3m, right? Plus 3 common 1 plus n plus 1 plus m is equals to 0. Okay. So x raised to the power 7 is equals to n plus 3m minus 22 plus 3 into 1 plus n plus 1 plus m is equals to 0. Okay. So can anyone tell me how can we proceed after this? Anyone?
Putting the options.
that can be done definitely. So you can just put the options and check for which combination of m and n it is coming out to be 0. Or if you want to solve it directly, how we should proceed is that if you look at
We can take this is equal to 0 and the second term as 0. So we'll have two linear equations in, I think,
correct,
M and N.
correct, exactly. So n plus 3m minus 22 has to be 0 because on the RHS there is no x to the power 7 into y term. And the constant term, which is 3 into 1 plus 1 plus m, has to be 0. Okay, so it's up to you, whichever way. So this needs to be solved to find
স্যার বলছি
m and
n প্লাস থ্রি এম মাইনাস 22 এটা তো জিরো নয় ওয়ান হতে হবে তো।
কোনটা
n প্লাস থ্রি এম মাইনাস 22
কেন
তাহলে তো
1 কেন
এক্স
হতে
ইন্টু
হবে
ওয়াই, তাহলেই তো মনে হয় না না ও আচ্ছা জিরো হতে হবে তখন।
না না হ্যাঁ on the RHS you don't have any term like x to the power 7 times y, right? That means the coefficient of this term has to be 0 for this equation to hold. Okay, is it fine with all of you? Others, any questions? Okay, is it fine with all of you? All right. So I think now you all can just work it out. So this part can be done straightforward. So this part I'm putting it as a homework for all of you. You need to either solve these two linear equations or you can go option wise as well. Over here you have the flexibility to choose either of them. All right. So whichever one is suitable for you, you can go with that approach. So any other questions on this? Anyone? Is it fine? Understood? Okay, perfect. So if there are no other questions, then let me move on to one last question for today. Consider the solution to the differential equation y dash of t is equals to minus of y cube plus y square plus 2y subject to y of 0 is equals to y naught, where y belongs from 0 to 2. Then limit t tends to infinity, y of t is how much? Option A 0, option B -1, option C 2, option D none. Okay, all right. So how can we start with this? Can anyone tell me?
We integrate it.
We have y
Correct.
prime of e is dy by dt essentially, So I think then we can variable separate and solve.
Correct. Absolutely. So the differential equation in this case is given in dy by dt format is equals to this. Right? So I can easily variable separate. That wouldn't be difficult. Right? And then integrate it out. Right? So the right hand side is pretty straightforward. That's not something to be worried about. What about the left hand side? How can we start solving this integration?
Taking common like y into y square plus y plus 2, and then that doing that thing like dividing into two parts a and b and finding the value of a b and then forming the equation.
Then we can also take the highest power of y common, something like that, and then maybe substitute.
Taking okay, highest power of y common. So actually I can do one more thing. This minus might be a little complicating over here. So इसको ऐसे लिख देता हूँ. Taking the minus common and putting it on the left. So if I take the highest power of y common,
স্যার আমরা ওটাকে ফ্যাক্টরাইজ করলেই তো হয়ে যাবে, তারপর তিনটে পার্টে ভেঙে যাবে, তারপর এ বি সি তে ডিভাইড করে সেইভাবে ভ্যালু বার করে এ করলেই তো হবে।
हाँ तो y out y square minus y minus 2 এটা কিসের ভাঙছে? Y square minus y minus 2 টা, so minus 2 plus 1.
Y minus 2 or y plus 1.
That would be the partial
This,
fraction approach to this.
sorry, what?
The partial fraction approach. We can just
Yes,
simply use partial fractions now.
yes. So I can write this as y into y plus 1 into y minus 2 dy is equals to minus integral dt. So for partial fractions, I'll write let. So there are three factors, right? Y plus 1 and y minus 2. So let this be equals to a upon y, b upon y plus 1, c upon y minus 2. And from this, we need to find a, b, and c, right? So if I equate both sides, then this will be a into y plus 1 into y minus 2 plus b into y minus 2 plus c into y plus 1 into y. So if I have to solve for a, I need to put the other two terms as 0. So I can put y as 0 and see what we are getting. Right? So for a, I need to put this. If I have to find b, I need to put y equals to minus 1 in this expression, right? And for c, I need to put y equals to 2. Correct? So can anyone quickly calculate and tell me what these three are giving you? What is a, b, and c? . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . .
A is equals to minus 1 by 2, sir.
Once more, minus
Minus 1 by 2.
minus 1 by 2. Okay.
Second টা হবে 1/3.
One by
Uh,
six.
1 by 6. So this will be minus 1 by 2 integration of 1 by y dy plus b is 1 by 3 integration of 1 by y plus 1 dy plus integration 1 by 6 y minus 2 dy is equals to minus t plus. Correct? Okay. All right. So now this integration can be done quite easily, right? So I think you all can take this from here now. So let me put this as well as homework for all of you. At least if the last part is not clear, at least try to find out the final solution of this differential equation, and then we'll come back and discuss the remaining solution in the next class. All right. Is it fine with all of you? Any questions? Okay, perfect. So I think we can stop here for today. So we have two questions to discuss tomorrow. So I'll request all of you to please at least give these two a try, and then we'll first discuss these two in the next class and continue. All right. So that's it for today's class, all of you. Thank you everyone for joining. See you all in the next class. See you all can disconnect. Thank you.